somehow we want to eliminate those denominators. So what I'm going to do is find the least common multiple of those denominators. We have 12, 3, 6, and 8. Okay, so what do? Right? We just have to list the multiples of each number. I'm not putting 0 in because 0 can't be a least common multiple, right? The least common multiple has to be greater than 0. So the 0 here, I didn't bother listing. If you did list it when solving this kind of equation, that's fine. I'm just explaining why I didn't put it down. We have 3. Okay, we keep going. I stopped at 24. I could have kept going, but I don't want to list too many numbers. 6 we have, 8, and we have 12. I actually stopped at 24 because I knew that 24 is a common multiple of 3, 6, and 8. And we also know 24 is a multiple of 12. So that's why I stopped at 24. But you can see that 24 is the first common multiple, that is. That is the first number in all these lists. So as you can see. I know it's tempting to write 12. It's tempting to write 12. 12 is not a multiple of 8, though. Okay? So that's why we're using these numbers. That's why we're using 24, excuse me. So we get 24. Okay, what do? Next, just like before, we're going to multiply both sides by 24, right? And then just like the previous example, excuse me, we distribute, okay? Distribute, that's what you do. And what ends up happening, as you can see here, is denominators are going to cancel, right? 12 goes bye-bye, 24 turns into 2. 3's gone, 24 becomes 8. 24 times 2, that just becomes 48. 24 is 6, right? 6 is gone, 24 becomes our friend 4. 8's gone, 24 turns into 3. Number 3. And that's how we get the equation below it. Okay, so we have 2x, right? Plus 16, plus 8 times 2x, right? That's 16x. Minus 24 times 2, right? That's going to be, what is that? That's minus 48x. We have 4x minus 3. So we have this equation. Well, we have this equation, which turns into this equation. Okay. And so we get this. And so from here, we just simplify the left-hand side, and we get minus 30x is 4x minus 3. Okay, it's just like the other example, right? Now we have an equation with no denominators. We're approaching it like we did in the beginning of chapter 1. Good. Sorry. Okay, I went back like this because I thought I made a mistake, but I didn't. So we have this equation to solve. And again, we want to get x all alone. X wants to be all alone. Okay? So we have minus 30x is 4x minus 3, right? So let's get 4x out of there. So we subtract 4x. We get minus 34x is minus 3. And I put the minus 3 over here. minus 34x is minus 3. Okay? Then we divide both sides by minus 34, right? Because again, we want to get x all alone. We don't want minus 34x. We want to know what x equals. All right? So we have minus 34x over minus 34 equals minus 3 over minus 34, right? We're dividing. What you do to one side, do to the other. And we get x all alone. The minus 34's cancel. And we get x is 3 over 34. All right. And again, one of the reasons we used the least common multiple, again, you can use any common multiple instead of 24. You could multiply all these denominators together if you wanted to. Not sure what you would get off the top of my head. But by using the least common multiple, this is actually in lowest terms. So, any questions on this example? I mean, if I'm going too fast, you know, don't be afraid to say something. I'll slow down. I won't get upset. Okay. So here, I figured it'd be good to do equations with absolute value. You know, mostly because I remember, not just from this semester, but from previous semesters as well, people sometimes do struggle with these. So I figured it'd be good to practice. So we have this here. So let's solve this equation. Well, let's get the absolute value all alone on the left side. You know, if you remember, that's actually what we dealt with earlier in the course. Well, that's easy to get, right? We just subtract 1 from each side. That's what I'm doing. So we get this. So we have this equation. Now, where people usually mess these up is this. Here, you actually get not just one equation, you get 2 equations, right? You have to see when is this here. Let me see something. Okay, I thought there was too much background noise, that's why I paused for a second. When is minus 3x plus 5 equal to 8? And you must solve when minus 3x plus 5 is negative 8. You have 2 equations here, okay? 2 equations. You want to know when what's in here equals 8 and what's in here equals minus 8. All right. If this instead of 8 were 0, then you would have one equation because minus 0 and 0 are the same. And if instead of 8 here you had a negative number, there would be no solutions because absolute value has to be non-negative. All right. So we have minus 3x plus 5, that's 8. Let's solve this equation. Just like before, we must get x all alone. So I subtract 5 from each side. As you can see, we get minus 3x is 3, right? So minus 3x is 3. You know, I subtract 5 from each side, right? The 5s are gone. We have minus 3x here. Then I moved it over, equals 3. Then we divide both sides by minus 3, right? Because we want to get x all alone. What happens? X becomes minus 1. X becomes minus 1. Right? Again, when we divide by minus 3, the minus 3's cancel. We'll get x is minus 1. Are we done yet? No. Right? We have this equation to solve as well. So let's solve that equation. Again, it's -8. What's nice is at least you can see that the steps, subtract 5, divide by -3, the steps are the same. Okay. So we again get x all alone. We're going to subtract 5 from each side, right? We get -3x equals -13. Excuse me, -13. We subtract 5 from each side. So we have -3x is -13. Okay? But again, we want x all alone, so we divide by -3. Doing so, okay, we get x equals 13/3. I mean, originally when we divide, we get -13/-3. The minus signs, however, cancel. You know, sap and sun rules. So that's what we get. Any questions on this? Okay. So here's another one we can do actually. Here is the same idea, namely, you know, we have absolute value, but we have two equations we have to solve. This is one of them. Okay? The other one is when instead of 4 here, we have -4, which is on the next slide. So we have this here, okay? Then what do? Again, we want to get x all alone, right? I just rewrote the equation here. So what can I do? I can add 7 to each side. Then we get 2/3 times x all alone on the left. And this equals 11. I just rewrote the equation here, as you can see. But again, we want to get x, right? So what do? Well, let's divide. If we divide, 2/3 is gone. We get x is 11 over 2/3. Now that's not really a great way to leave it though. You know, we can do better than that. So what we can do is this. 11 over 2/3. Well, remember, that's the same thing as 11 divided by 2/3. That's really the same thing. But when you divide fractions, I think we touched on this in the beginning of the course. When you divide fractions, that's the same as multiplying by the reciprocal of the second fraction. In other words, 11 divided by 2/3